Okay guys, in this video we're going to look again at the law of sines in order to solve an oblique triangle, but we're going to look at the side-side angle case, which is a little bit different than the first two cases in which we know two of the angles to begin with. And so in this particular instance, we're only going to know one of our three angles, meaning that we're actually going to have to go solve for the other two algebraically. Now, the good news, at least with the side-side angle case, is that we know two of our three sides. Now, one thing that I want to make sure that you know here is that you cannot assume that you can use the Pythagorean theorem because we're not actually sure that either C or B is a 90-degree angle. And so to use the law of sines here, let's go ahead and get ourselves set up with at least what we know. We're going to write out for triangle ABC here the unknown length, so we know that this is, let me get this altered here really quickly. Okay, so let's try this again. We know, that this side length is C, and we know lowercase a, and we know lowercase b. And so to write out what we do and what we don't know, we have A, B, and C. Always good to organize it this way. We have the measure of angle A, the measure of angle B, and the measure of angle C. Let's go ahead and get these filled out with what we know. So we know the measure of angle A is 40 degrees here. And then at least with these other two sides, we know lowercase a is equal to 3 and our lowercase b is equal to 2. And so in terms of can we use the law of sines here in order to solve this problem? The neat thing is, of course, yes, because we have a side angle pair. And again, you can always see if side angle pairs exist if you made your data matrix over here because, well, they lie across from one another, lowercase a and uppercase a. So because I know this side angle pair here, we're going to use that in order to, I would say first, find the measure of angle B because we can set this ratio up here. So because actually I'm finding the angle B this time, what I'm going to do is I'm going to write the angle B on top of our fraction here. And so we say the sine of angle B, which we don't know, is over lowercase b, which is 2. And then we would say the sine of angle A, which is known, the sine of angle A, which is 40 degrees, this would be divided by lowercase a across from it. So the thing here is we can, as we normally do, go ahead and do our cross product. We get 2 times the sine of 40 degrees, okay? That would have to be equal to 3 times the sine of b. Now the thing here is when we're solving for an angle, okay, what we want to do first, and let me just write this out here. When solving for the angle, okay, we're going to isolate the trig function. Isolate the trig function. And then what we're going to do is use the appropriate inverse trig function to solve for the angle. And so when we look at this particular instance here, we can see that to get the trig function by itself, which our trig function is this sine of b part, we're going to have to divide both sides by 3. And so what we get on the left here is 2 times the sine of 40 degrees, and this is all over 3, and this is equal to the sine of b. Now, in terms of using the appropriate inverse trig function, here's what I want you to keep in mind. We are undoing a sine function. And so to undo this, we're going to take the sine inverse of everything on the left and the sine inverse of everything on the right. Now, we had sine of b on the right, but what we know is that sine inverse and sine cancel out, and what we get left with is just the angle b. Now, on the left side, we have 2 sine of 40 degrees all over 3, and so that's still what our angle is equal to. It's the sine inverse of 2 sine of 40 degrees all over 3. But the thing here is this, we can use a calculator in order to obtain this value. So the way we're going to do this is, of course, we can type this in exactly how you see it. We'll hit sine inverse first, sine inverse, and we can put on top. Now, see, the thing is you have to put parentheses. We get 2 times the sine of 40 degrees, end parenthesis, end parenthesis. And so you can see 2 sine 40 degrees is all in parentheses here. And then we'd have to divide this all by 3. Now, for somebody like me, really comfortable with the calculator keys, I might not have a problem typing all that in with parentheses. But for somebody else that might have a little bit of difficulty with it, another approach might be this. Let's go ahead and evaluate for what this decimal is on the inside of here. So for instance, we could just right now just say 2 sine of 40 degrees, 2 end parentheses, divided by 3. We're going to get a decimal here, but what we want to do is we want to take the sine inverse of our answer. And so our answer, this a and s behind your negative key here, we can just say, let's take the sine inverse of what I just got as a decimal, and you're going to see that we get the same angle that I had previously. So because my original angle goes out to the nearest whole number, I'm going to take this out to the nearest tenth of a degree, and so we would get 25.4 degrees. I'm going to write that here. This is approximately 25.4 degrees. So I put a box around this. I would certainly go over here and say this is about 25.4 degrees, and I would also go up to my picture and put this in to test at least my reasonability here. Say, is this reasonable? And I think it totally is reasonable. So now the neat thing about having two angles is, well, I suppose we could find the third angle. So let's go ahead and take our 25.4, we'll use our rounded value, and add it to 40. We get a total of, for these two angles, 65.4 degrees. And then I'm just going to take 180 off of this. Even though it's going to be negative, it'll tell us that the third angle must contain 114.6 degrees of rotation. So 114.6. So in order to solve now for our remaining side here, we're still going to use the law of sines, but what I want to do is I want to use the initial ratio that we had set up here that we were given, the initial side angle pair that we were given. So we're going to do this time. I'm going to go ahead and put my 113.4 up here, but we can use that and this one in order to set up and solve a proportion to find this final side. So because I'm solving for side length C, I'm going to put that on top of my ratio. We're going to say C over the sine of uppercase C. The sine of uppercase C is 113.4 degrees, and this must be equal to, I suppose, A, lowercase a, which is our 3, over the sine of the angle across from it, which is the sine of 40. So again, let's go ahead and do our cross product here and set it equal to each other. We will get C times the sine of 40 degrees, and this would be C times the sine of 40 degrees. I'm getting ahead of myself here. This is equal to 3 times the sine of 113.4 degrees. And so let's go ahead and divide both sides to get C by itself here by the sine of 40 degrees. And what we end up with is the fact that C is equal to this exact value right here. So let's go ahead and, again, with our calculators, let's get a decimal here. We would say on top, everything, 3 times the sine of 113.4, two end parentheses, so all of this divided by the sine of 40 should give us then our C value. So we say about 4.3 here, about 4.3 units, okay? And so I would go put this over here, both in my data matrix, and I would label the side of my triangle here. So testing for reasonability, let's just go ahead and check. The largest or longest side was opposite the largest angle of rotation. The smallest side, 2, was opposite the shortest angle of rotation, or smallest angle of rotation, and then our intermediate side was opposite our intermediate angle of rotation. Cheers.